Okay, so that's the purpose is to make sure your computer's ready. You have to install that little Chrome plugin. Sometimes there's some settings that need to be changed, like on your webcam and on some firewall things and stuff like that. So that's that's why I have that there. Okay, so the first time we'll use HonorLock for real will be next week in your lab quiz on Thursday. Okay, so your computer needs to be ready for it by that time. Okay, so there's like 6 of you that are still trying to figure out how to get that set up. Okay, so take that HonorLock practice quiz and figure it out. Okay, their tech support is super helpful. Okay, so if your computer is just giving you errors, if it's not working, then click on the little chat on the side, right next to the HonorLock thing as you go to take that quiz, and you can just chat with them right there, or there's a number right there you can call too. Get that figured out, because by Thursday you've got to have that ready. You will not be able to take the lab quiz if HonorLock isn't set up on your computer. Okay, and secondly, you can't use a mobile platform for that. Okay, so you can't use an iPad, you can't use a tablet, can't use a phone. It has to be on a laptop if there's ever a HonorLock enabled exam or quiz. It's got to be on a laptop. Okay, so that could be obviously Windows or Mac, but it can't can't be any of those others mobile platforms. Okay, other thing is just a good tip for Canvas in general is to always use Chrome. Okay, so some of you might normally use Safari or Firefox or Internet Explorer, something like that. Don't ever do that with Canvas stuff. Okay, Canvas is Chrome only. Okay, some of the quizzes, like the quiz you take this Friday, if you try to take it with Chrome, or sorry, if you try to take it with one of the other browsers like Firefox or Safari especially, some of the questions won't show up right, and there's a chance you'll get it wrong just because it doesn't format right. Okay, so use Chrome always for Canvas assessments, and then definitely for HonorLock enabled assessments, it has to be Chrome. Okay, any questions on that? Okay.
So the quiz this week doesn't have HonorLock?
None of the Friday quizzes have HonorLock, yeah.
And those are open notes?
Those are open notes.
Just
absolutely.
The exams aren't, okay.
The exams are Fridays as well. Those do have HonorLock and they're not open note. Yeah.
Okay, thank you.
Great.
I had a question.
Yeah.
For the quiz next week for the lab, are we, I saw in the pamphlet how there's bones on there and you have to like identify it. How exactly is that going to work for the online format?
Yeah, so it'll just be an image in a Canvas question of a bone. Okay. And there's 3 types of questions you could possibly have. One would be name the bone, right? You just type it in and it's not multiple choice, so you type in the name of the bone in a fill in the blank type question. That would be one type, name the bone. Another type would be, what side is this? Is this a right or a left? Okay, those ones are multiple choice, so you just click right or left. But then, sorry, go ahead.
Go ahead, it's okay.
Okay, yeah, one more type of question is name the structure. Okay, so it'll be a picture of the bone. There'll be a little circle around something or an arrow pointing to one part of that bone. And then you have to just type in the name of that structure.
So we wouldn't be able to like move it virtually, like on the screen, it wouldn't move around?
No, you can't. Nope, no, you cannot move it, unfortunately. Yeah, and actually that's how it is during, if we were face-to-face, it'd be the same thing. You're not allowed to touch the bones during the practical, and all the quizzes are electronic, even when you're face-to-face. So that part didn't really change too much. It's just when you study it, you can't touch it. That's the part that's different from a normal semester.
I have a question about also about the lab quiz next week. Miss Dr. Mahoney said that we could use our lab partners. So how does that work with HonorLock? Will it like get us in trouble if we're like talking with another person, or how
you can't use lab partners during the quiz.
Oh, okay.
You can use lab partners. So there's a lab next week that you have to do, which is an online lab. Yeah, and I forgot to say that in my 2 sections, so that's good for everybody to hear. So there's a chemistry lab. I'm going to show you where that is in Canvas here real quick. And that you can work with a partner or whoever you want in the class to complete that lab. Okay. But when it comes to the quiz that you do Thursday morning or Thursday during the lab time, that is on your own.
Okay, thank you. Yeah, I think I just got that mixed up. Thank you.
That's a good clarification. Thank you. Yeah, other questions?
If we did have a partner, would we hand in the same copy as them, or would we do our own work?
You do your own work, yeah. So there's going to be a Canvas. It's a Canvas quiz, but it's not like it's not like the lab quiz. It's just something that you're going to fill in the answers from the lab worksheet, and you guys would just be filling that out together, but doing your own work. Yeah.
So for the HonorLock thing, the practice HonorLock quiz on the HonorLock tab in Canvas, that's just to make sure that HonorLock's working for us, right?
Yes, yes, and you don't want to wait until your lab time to figure out if it's working or not, because yeah, you've only got 15 minutes to finish that lab quiz and turn it in, so that's why you want to do that ahead of time.
And the lecture quiz that's today, there's one today, and then that one's just for like a recap of the week, right? And that's open note.
Exactly, that's open notes,
Okay.
open book, and it's over just the first 2 days. It's not over the material from today.
Okay.
Yeah, good, good. All good clarifying questions. What else? Anything else?
About how long would you say today's quiz would take?
So there's an 18-minute time limit on it. Okay, so it won't take any longer than that.
Okay,
because it'll shut you off at 18 minutes.
Sounds good.
But yeah, most people, so you need to study though. So if you just jump in there without studying, people typically don't do well, and that's why I put the time limit on there. So you do have to study ahead of time to prepare for it.
Is it stuff just like, is everything covered in the notes, or is it stuff from the book too?
Just the notes. Yep, just the notes. So that's how I do those Friday quizzes and the exams. The notes are fair game. Obviously, that stuff is in the book as well, but I don't pull things from the book that aren't in the notes. Okay.
I have a quick question about Reef. Sorry. I'm on my phone with it because since I'm on my iPad, it won't let me have like video and be split screen.
Okay.
And for the questions, it like won't show me the questions. It says like hidden by your instructor. Are we supposed to see the questions, or just
I don't have any
randomly
questions.
answer?
Yeah, I don't have any questions activated yet. So you'll see when we all start it, and then you should see it pop up. Yeah.
Okay.
I think there's like a button you can press for check-in. It's like 47 of you have checked in already. That's the attendance piece, but you also get attendance just by answering the questions too. So.
Okay.
Yeah. So yeah, a couple more of you are checking in. That's good. Good. Okay. And then just a reminder, the first Mastering A&P assignment is due on Monday, and those are due by class time, okay? So by 1:30. So that's not due by midnight, that's due before class starts by 1:30, okay? And so again, you're gonna access that through Canvas, through the My Lab and Mastering link. Okay, so that's it for this week. Any other questions on the stuff we're doing this week or the lab stuff?
Is the Mastering A&P quiz on this week's material, or is it for next week's material?
Mastering A&P is always ahead of time.
Okay.
And so the way that works is it's really just to prepare you for the week, okay? So it's over the readings. If you go to the syllabus or the weekly overview page, it says pages to read before class. Those are the pages that it's over.
Got it, thank you.
Okay, and there's no time limit on those. They're not super hard questions. You just take your time, read the book as you're doing it. Most people get average above a 9 out of 10 on all of them, or over 90% on all of them. You just got to take some time and do those. But it just helps you prepare for the week.
Okay, thank you.
All right. Okay, I'm going to go ahead and share my screen so I can just walk you through one thing on Canvas here. A couple things just to get ready for next week. So next week, there's a lot going on, you guys, okay? So there's a lot happening in this class next week. So let me just walk you through that, okay? This is our week 2 overview page, okay? So again, you've got this here, which is going to be the links to the videos. This actually might be there if I refresh it. I posted the video for Friday already, because Friday is, there it is, yeah. So Friday is our first TBL day. So what that means is you watch this video ahead of time before you come to class on Friday, and you're going to take a short 10-question quiz on that material from from that lecture. So it's an online lecture. I'm just using my iPad, doing kind of a voiceover, filling things in like I normally would. So you would want to have your notes with you, and you're studying that material as you watch it, and then you study it some more, get ready for that quiz on Friday, okay? It's only a 10-point total quiz, and 4 of those points, so you're gonna take the quiz twice. You're gonna, as soon as class starts, you're gonna take what's called the IRAT, which is right here, okay? It's 10 points, I'm sorry, it's 10 questions, but only 4 points, okay? And then once everybody's done with that, I'm gonna send you into your teams, and then you're gonna take that exact same quiz again without getting any feedback as a team, okay? So you're gonna discuss each answer, decide on an answer for the group for each number, and then take that again, okay? So that, the team part is worth 6 points, okay? So 60% goes to the team, 40% to the individual, okay? So that's how we do that. And then we'll walk through some activities to dive into that material a little bit more, and that's how we do those TBL days, okay? So that's why that video is already posted. Okay, here's the lab handout that you're going to work with for this opens up for you on Monday at 7 a.m. Okay, so anytime between Monday at 7 a.m. and Friday at 5 p.m. you can work on this lab, and then you can submit it here. This is the one that's kind of just like a little Canvas quiz, but you submit all your answers there. Okay, so anytime throughout the week you can do that. Okay, so you've got Mastering A&P on Monday. We've got our lab quiz on Thursday, and you're going to click on the one that your section belongs to, right? So Thursday at 8 a.m. is A, Thursday at 1:30 is B, and Thursday at 5:30 is C. Okay, chemistry lab, this will take you right to the submission page, due at 5, okay? And then the IRAT and TRAT start of class on Friday, and we do still have a lecture quiz that's due by 11:59 p.m. next week, okay? So it's a busy week, all right? We don't have a synchronous lab session. We'll just have synchronous classes Monday and Friday. Okay, questions about those things? Go ahead, Eddie.
Okay, so for the lab quiz, do we at the assigned time, or can we take it any time during the day?
You have to take it at your start time of your lab. Yeah, and the reason for that is because we don't want people sharing answers. They take it beforehand and say, hey, this one, you know, this is what you should study because this is going to be on it, right? So they are different lab or different quizzes for every section, okay? So the people who are in the 8 a.m. lab, you have to start taking that right at 8 a.m., okay? And you have 15 minutes to take it, okay? The 1:30 lab right at 1:30, the 5:30 lab right at 5:30, okay? So log in before that, get ready, get yourself set up, get all ready, and then it'll open up for you right at the start of your lab time.
Okay, thank you.
Yeah. Okay, any other questions on what I just said?
Yeah, so to prepare for each of those things, so for Mastering A&P, there's no preparing, just have your book with you.
No preparation needed, no.
And then the lab quiz, it's like study the bones in that handout you gave us.
Yes, and let me show you a little bit more on some tools that I added for that. So when you go to the modules page, I put in this module called Lab Resources. Click on Skeleton Lab Resources. And I put all kinds of stuff here yesterday. Okay, so you got the lab handout that you should already have. This is instructions on how to get to that practice anatomy lab through Mastering A&P. It's still working. It's not 2.0 anymore. You'll see it's like 3.1 now or something, but it's super helpful. Let me just show you that right here. It's still working. Good, yeah, so this is an example of what it looks like. So you have images of all the bones, and you just hover over things and it'll tell you what stuff is. So that's very helpful. Okay, it has all the different bones, all the muscles and everything. Okay, so that'll be through that. Yeah, and then we've got these bone flashcards, which are very helpful, especially for figuring out the left and the right. Let me just show you what that looks like here real quick. So they look like this if you haven't downloaded those yet. They're very nice images, and they're good practice for figuring out left versus right, because you don't actually have different bones to do that with like you normally would, but you can use these to practice that. Okay, and then we've got some of the slides that I presented and that Professor Mahoney presented for both the appendicular and axial. And then these videos of Dr. Fleester walking you through the bones. They're only about 10 minutes each, but I would recommend checking those out for a little bit more information. And then this, I recorded the last lab that I did yesterday. So if you want to go back in and review what we talked about in lab, that's right there.
Awesome, thank you.
Yeah.
And then for the new quizzes, the IRAT and those two, How do we prepare for those again?
So you prepare for those by watching the YouTube video that
Okay.
is linked right there under Friday's class in the week 2 overview page. So right here, week 2. And then I'm going to I post all the video links here, but this one is already here for Friday. So you watch that video,
Okay.
fill in your notes just like you would in class, and study those. And because I don't actually teach on that stuff before you take the quiz. That's kind of, you learn it ahead of time and take a quiz on it.
Okay, and it's not open note, correct?
Not open note.
Okay.
Yeah.
And then last question, this might be a silly question. I don't even know if you're allowed to share. But for the lab quiz, is it going to be real pictures of bones or like drawings / cartoons?
Yeah, more real pictures. Yeah,
okay.
But there's a little bit of a mix, but it's mostly real. Yeah.
Okay, thank you so much.
Yeah, great questions. No, there's a lot to figure out, and so I'm happy to answer your questions. Anything else? Okay. All right, we're gonna get rolling here. Let me share my screen from my iPad. Gonna present from that here. I promised you a couple family photos, so I'm going to do that real quick. Here we go. Let's see. Yeah, there we go. So here's the fam. Didn't get to show you guys the other day, but here we are. We got my wife Monique here, Soren, our 11-year-old, Christian, our 7-year-old, and little Evie girl, our almost 4-year-old. And I had to take a couple pictures of her this morning. Here she comes. She'll be there in a sec with her mask on. Got to wear a mask before I take her to preschool. And I get the privilege of doing her hair a lot of mornings. So she wanted a side pony this morning. So that was that was what we did. Yeah. So there we are. Don't worry, you'll get to see more Evie girl photos as the time goes on. All right, guys, so we're going to dive into this here, talking about solutions, cytoplasm, and diffusion. Okay, so this whole first part of the class is primarily talking about some basic chemistry as well as some basic cellular physiology, and then we get into, after that, we'll get into talking about cells and cell functions and then tissues, as well as then we finally move into some organ systems when we get into the skin, and then bones and muscles and nervous system. That's kind of the basis of the semester. But so we're kind of just in that part where we're talking about general properties of chemicals and cells. So a very important part of all of this is solutions. Okay, so the definition of a solution is something that's a homogeneous mixture of components. Okay, and it always includes a solvent, which is the liquid part. Okay, a solute, which is the non-liquid part, the stuff that's dissolved into the solution. So when we put the solvent and solute together, we've got the solution. Okay, water is the universal solvent, as you saw from the class on Wednesday. Hopefully you've watched that. Water is the universal solvent, and it dissolves most things. It dissolves ionic solutes. It dissolves most polar substances, but it doesn't dissolve most non-polar things like lipids, fats, and many other chemicals that are non-polar. Okay. And we have something kind of in between, not quite a solution, but not quite a solid, and that's called a colloid. And a colloid is a heterogeneous mixture where we have these larger solute particles. It's a little bit more gel-like. Think of like actually Jell-O when you think of a colloid. And the best way to think of the homogeneous versus heterogeneous is if I just took a scoop of a solution and from one place and took a scoop from another place and analyzed the components in those two, I would have about the same number of each of the particles and the amount of solute in each of those two little scoops that I took. But if I did that with a colloid, I wouldn't end up with the same exact mixture in each of those, okay? Because it's not quite all mixed up perfectly like it is with a solution. Okay, so one of the primary things we have in the solution of our body is different kinds of salts. Okay, and so salts are ionic compounds that have a cation and an anion. okay? All salts are something called electrolytes, which that just means they can conduct electricity, okay? And the properties of these are when they're solid, they're crystal, and then they dissolve in water quite easily, okay? And they dissolve in water due to the fact that water is polar, okay? So hopefully you watched that video for Wednesday's class because that explained that well. The hydrogen side of water is positively charged and the oxygen side of water is negatively charged, okay? And so we'll see in a sec on the next slide how that kind of pulls those apart, okay? So what makes a particle an ion? If it's charged, right? Has a charge to it, positive or negative. And ionic bonds are something we talked about before. And so we have these ionic bonds. A good example is just in regular table salt like this between sodium and chloride. And really it's because they got close to each other, sodium and chloride did. Sodium gave up an electron to chloride, right? So as it lost that negative charge, it became positive, right? And as chloride gained that negative charge, it became negative. And then they were drawn to each other because of that opposite charge. And then they stuck to each other because of the opposite charge. That's an ionic bond, okay? So when we look at water and its ability to pull things apart, we can see that here. Okay, so if we use that example of putting a bunch of salt in water, we can see here how water is nicely, has those positive sides on the hydrogen and the negative over here, right? And you can see the chloride is a negative charge. So the positive parts of the water stick to the negative parts, which is the chloride. And then we see up here, the negative side of water sticks to the sodium. And by doing that at the same time, it pulls the sodium and the chloride apart, right? And that's how it dissolves an ionic solution or an ionic chemical like that, okay? We can also do the same thing with a polar molecule, like carbon monoxide, pulls it apart, but we don't see that with a non-polar molecule. They just completely separate. That would be like putting oil into water, right? And you see that complete separation, okay? So A and B would mix well, but C would not, right? Okay, any questions on that so far? Okay. All right, so the reason we're kind of talking about that is multiple, but one of the reasons is to talk about diffusion. The other reason is because we're going to talk about what the inside of a cell is made up of today. And the inside of a cell is made up of something called cytoplasm. And cytoplasm is really all the contents of the cell between the membrane and the nucleus. Okay, so everything else we find inside of that cell that's not, the two boundaries are the membrane and the nucleus. Okay, so it's made up of multiple things. One of the things, the liquid-ish or component is cytosol. Okay, and cytosol is even somewhere between an actual solution and a colloid. Okay, so it's semi-solid, semi-transparent, again, somewhere between a solution and a colloid mixture. Okay, so it's somewhat liquidy, but it's not like Jello. It doesn't move at all. There's yeah, so it's somewhere in between those. So it contains all of our dissolved substances like salts, glucose, gases, amino acids, proteins, ATPs. Okay, so that's the one major component, and then we have organelles. Right, so this would be like our mitochondria, our rough endoplasmic reticulum, smooth endoplasmic reticulum, Golgi apparatus, all these different organelles we're going to talk more about next week. Okay, those are part of the cytoplasm. We have inclusions depending on the type of cell. For example, muscle and liver cells contain a bunch of stored carbohydrates in the form of glycogen. Okay, and then we also have the cytoskeleton in there, and these are structural proteins that hold the cell together, serve as tracks, allow the cell to move, multiple things like that. So we'll be looking at some of those cytoskeleton proteins here in one sec. Okay, so here it is. So there's three main types of cytoskeleton proteins, and there's different filaments, okay? So different protein structures that form the support, movement, and shape of the cell, okay? There's actin filaments, intermediate filaments, and then others called microtubules, okay? And really just the primary idea would just be to know the general functions of these, okay? So functions of the actin filaments, They give the cell its shape, give it strength, and then they allow for movement of the cell as well. Whereas those intermediate filaments, they're the largest, the most, or not the largest, but the most stable and the most permanent, okay? And they're primarily for support, providing physical structural support for the cell. And then lastly, those microtubules, these are the largest, but they're hollow. And these are the pictures of each of them right here. Okay, so again, give a strong framework, but also provide these tracks for vesicles to travel up and down. One of the most amazing videos that I normally show, but I haven't quite figured out how to show a video on YouTube from my iPad on Zoom. That wasn't quite working. So I'll send the links for those videos. In our neurons, all of the cell bodies of our neurons are in our central nervous system. So that's either in our brain or our spinal cord. And then the axons of those neurons travel all the way down to like the tips of our toes or the ends of our fingers, okay? And so when we want to activate a muscle down in our foot, we've got to send a signal all the way down, right? But at the end of that neuron is a bunch of neurotransmitters, okay? But the neurotransmitters are actually made way up in the central nervous system in the cell body. And so to get those neurotransmitters down there, they have to be carried down, and sometimes 2 to 3 feet in length, okay? And there's these little motor proteins that literally walk down these little train tracks, which are the microtubules, and carry the neurotransmitters down. And it's an absolutely fascinating little video to watch the depiction of that. So I'll send the link to that video because it's supposed to be right here, but it's not working when I try to do it on my iPad here. So, and in fact, one of the parts of the pathology of Alzheimer's disease is that the microtubule structure within neurons in the brain starts breaking down. And so if we break those train tracks inside of those neurons, we can't get neurotransmitters to the end of the neuron anymore. And the neuron can't really do anything. If it can't release neurotransmitters, it can't release those neurotransmitters, it can't communicate, and it really becomes dysfunctional completely. So, okay, any questions on that? Okay. All right, so let's take a second and yeah, just go ahead and which cytoskeleton filaments above are involved in moving the vesicles of proteins in the video that you just watched, that, or the one I just talked about, okay? Pretty simple question, but let's just do it to get you opened up on that Reef mobile app, okay? Go ahead and, yeah, you should be able to do it here in 1 sec. Oops. Yeah. Okay, that might not work for my iPad. I thought it could. Okay, well, that didn't work. I was trying to do it for my iPad today, but that wasn't going to work, I guess. Okay, that's all right. Yeah, we don't need to do that yet. Okay, so which one is it? Obviously, it's the one we were just talking about, which is this one, right? Those microtubules. So the answer would have been C there. Okay, any questions on that so far, the cytoskeleton? Okay. All right. So other kind of related topics to this are not only what's inside the cell, but things that stick out of cells too. Okay. And so we have multiple cellular extensions to kind of just introduce here. And this first part of the class, we kind of end up hitting a bunch of topics that are somehow related, but doesn't quite seem like a perfect train of thought. So that's why we're kind of jumping around a little bit from the cytoskeleton to cellular extensions. Okay. So multiple cellular extensions. One of these is called a cilia. Okay, and you guys have probably learned these about in other biology classes. So small whip-like extensions. They're usually occur in large numbers, like you see here in the respiratory tract. Okay, the function is to move particles across the surface of the cell. Okay, and there's also some cool videos about this one that I'll make available to you after class as well, that show that the little moving of the cilia is not random at all. It's actually very direct in trying to move things. So for example, when you inhale a piece of dust and it gets caught in the mucous membranes of your respiratory tract, it would be stuck in the cilia like this, right? It'd be right here. And those little cilia are whipping in the direction to send that little particle back up, and makes it back up your throat to where you can hawk up a loogie, right? and someone's doing it right now. That's good timing. And yeah, you can hawk that up and get it out, right? Or you can swallow it and get it into your stomach and get it out of your body that way. But that's exactly what your cilia do, is move those things up. Okay, thanks for that sound effect. I didn't plan that at all, but that was exactly what I needed right there. I don't know who it was, so. But, all right. Okay, so that's the cilia. A couple other cellular extensions that are important here. Flagella, that's one big, powerful extension instead of a bunch of little ones like in the cilia. The primary example in humans is with sperm cells. Okay, and then we have microvilli, which we'll talk about more next semester when we talk about the digestive tract. The job of these guys is really to increase the surface area of a cell. Okay, so like these little fingers sticking up like this, and they really allow for us to embed a bunch of little enzymes in all the way through here. So we got little enzymes embedded all the way here. And so in the digestive tract in particular, those are called the brush border enzymes, which are carbohydrates and our lipids and our proteins have to interact with those in order to be broken down fully before we can absorb them. Okay, so that's the example there. So the more space we have to plug those little proteins in, those little enzymes, then the better off we are. And that's exactly what the job of microvilli is. Okay, so all of this definitely related to this idea when we're talking about solutions and the inside of cells. We really need to get to the idea of diffusion of particles moving particles or molecules moving from an area of higher concentration to lower. Okay, so very important concept. We're going to talk about some different ways that particles and molecules do that. Okay. It goes very fast, in particular when we're talking about movement across the cell membrane, because that's so small, okay? So a cell membrane is about 1/1000th of the thickness of a piece of paper, of a normal piece of paper that's right now. So it's really small, right? And so when we think about something moving across that membrane, that's not very far to go, okay? So yeah, so diffusion is a movement from high concentration to lower concentration. Okay, so there's multiple types of diffusion, and we're going to talk about those. Okay, so simple diffusion is very basic. It really just means substances that can pass freely over a membrane. Okay, they do that, right? So they go from higher concentration to lower. And some of these things we're really glad they can do that, like oxygen, right? We don't need special transporters to get oxygen inside of our cells. It just passes right through the membrane. Okay, that's good. Same thing with CO2. We mostly want to get it out of our cells, back into the blood. Certain vitamins can do this as well. And yeah, oops. And yeah, so that's simple diffusion. Facilitated diffusion is when something is going to go with its concentration gradient, but it needs some help doing that. Okay, and it can either do that by being carried by a transport protein, and that kind of attaches the molecule to it and kind of carries it across. This is how glucose is carried through the membrane. Or it can be channel mediated, where it really just like a gate opens up for it to go through. This is how water passes through this way, and some ions pass through this way because they're charged. They can't quite get through the membrane as easily. Okay, so we got simple and facilitated. And then those are both forms of passive diffusion, meaning that things are going from high to low. But then we also sometimes need to move things against their concentration gradient, right? Sometimes we got things that are already have a higher concentration inside the cell, but we need to get more of it in there, right? So in that case, that takes energy to do that, and that's active transport. So movement of molecules against their concentration gradient. So that would be going from low to high instead of the opposite, which is normally high to low. Okay, so this requires an input of energy from somewhere. And we've got two options for where that energy comes from. Number one, it can be directly from adenosine triphosphate. This is our body's chemical current. This is all of biology's chemical currency of energy. Okay, we'll talk more about it soon. Okay, but it's really our energy source. Okay, or it can be from the concentration gradient of another molecule. Okay, this one's called primary. This one's called secondary active transport.
What would another molecule be?
Well, I'll give you some examples here in 1 sec. It's a good question. Okay. Yeah, I'll give you one right now just to kind of get you thinking about it. So when we talk about the digestive system, we'll see that when we need to absorb glucose, a lot of times there's already more glucose inside of our intestinal cells than there is in the digestive tract. So we're fighting against our gradient. When we drink a soda that's got some sugar in it, we need to get that glucose in, but a lot of times it's fighting against the gradient because there's already more glucose in. So the way that we handle that is we use the concentration gradient of something that almost always has a concentration gradient to come in, which is sodium. Okay, sodium always has a higher concentration outside of cells for the most part versus inside. So there's always a strong gradient to push sodium in. So what happens is you kind of picture like a catapult type system where you have the glucose on one side of a catapult, right? So you picture a catapult with like a teeter-totter type thing, right? Glucose on one side, and then you pretty much drop that sodium on the other side and it slings the glucose across. That's exactly how secondary active transport works. And it's these perfectly little designed proteins that do just that. They take that power from sodium flying across the membrane fast, and it pulls the glucose with it. So that's one example.
Thank you.
Okay, you're welcome. Okay, so here's what I'm going to do. I want to send you briefly to your breakout rooms to work through this question here. Okay, so I'd like you to, there's 5 pictures here representing those five different types of movement across a cell that we just talked about. Okay, so I'd like you to order these in the correct order, okay, just with your team. But then I'm going to figure out how to get the reef thing working while you're doing that. And you can send in answer the question with the letter of the one that would represent secondary active transport. Okay. All right. So let's try these breakout rooms. I think we're pretty close to getting these things to work. All right. Here we go. Okay, there's a few of you I'm going to send in 1 sec. I don't know why it's still not working for you guys. Okay, go ahead. Good. again. Sorry about that. Okay. Okay, so one of our, we talked about one homeostatic principle being pH, and there'll be some questions on the quiz on that for sure. But another very important homeostatic principle in the body is it has to do with osmosis, okay? And so osmosis is just kind of an extension of diffusion, but it's primarily talking about substances and talking about water, okay? So diffusion again was a substance from higher to lower concentration, but osmosis is diffusion of a solvent, most of the time water, through a selectively permeable membrane. Okay, so it's an extension of the concept of diffusion. Okay, and there's different ways that water moves across cell membranes. One is just because the lipid bilayer, picture kind of lipids and fat, how it kind of jiggles a little bit on our bodies. That's kind of how cell membranes are too. They jiggle around a little bit, and when they jiggle around, they open up little cracks to allow some water through. Okay, so that's part of it. But then we also have special proteins that allow for water to pass through called aquaporins. Okay, and they can kind of let one water molecule in at a time, very tiny, obviously. Okay, so then there's this concept of osmolarity that we'll talk about with solutions. And we have these little brackets, which means concentration. So this means the concentration of all solute particles in a solution. Okay, so solute's the stuff, right? Solvent was the liquid. Okay, so again, that key definition of a solution equals the solute plus the solvent. Okay, so we'll talk about that concept of osmolarity a little more here. Okay, so a few other terms that are very important to understand in this context. Osmotic pressure is the tendency of water to move into or out of a space due to osmosis, and due to the osmolarity of that space, due to the concentration of particles in that space. Okay, and so when we talk about a space that has high osmotic pressure, that's due to more particles relative to the fluid. And these terms are always relative, okay? So we're talking about one side of the membrane compared to the other side of the membrane. That's where the relativity part comes in, okay? So if we say the inside of the cell has high osmotic pressure, we're also saying that the outside of the cell has lower osmotic pressure, okay? They're just relative to each other. They're always going to be that way, okay? So then we've got low osmotic pressure is due to less particles relative to fluid. Okay, so if we got high osmotic pressure, that has the ability to pull fluid towards it. Okay, so super salty solutions, they have high osmotic pressure and they can pull fluid towards themselves. Okay, so why do you get dehydrated when you drink a ton of salt water? It's because the fluid around your cells gets full of salt, gets high osmotic pressure, and that draws water out of your cells. Okay, because that fluid around your cells now has high osmotic pressure, has the ability to pull that fluid out. Okay, low osmotic pressure is the opposite. It doesn't have the ability to hold on to fluid, so it lets it go. Okay.
I have a question.
Yes, please.
So what about like when you're placed in salt water? Why do you get dehydrated then?
You mean just like laying in salt water?
Yeah, like your fingers get all wrinkled and I mean, I feel like I get dehydrated when I'm in salt water.
Yeah, I mean, I don't know if it's necessarily pulling any fluid out of your blood, but it definitely dehydrates and kind of just softens the proteins in your skin. That's typically why your skin gets kind of, you know, raisiny like that and wrinkly, is because the water is really just soaking into the protein part of your skin and just kind of softening it. But I would guess laying in water for a long enough time may also just kind of be able to pull a little bit of fluid out of your skin and possibly dehydrate you a little bit. But it's not something that I've heard of being like a huge risk of swimming in the ocean or anything like that. But
sounds good, thank you.
Yeah, for sure. Okay,
I had a question as well.
Go ahead.
Sorry.
Yeah.
So would high osmotic pressure mean that the cell would be hypotonic or hypertonic, like which?
Yeah, good question. We're going to get there in a sec, okay?
So okay, sorry.
Thank you. No, that's okay. I don't introduce tonicity terms quite yet, just because we got to get this concept down first, but it's okay. coming quick, okay?
Thank you.
Yeah, for sure. Okay, so if a solution has high osmotic pressure, it also has high osmolarity. Okay, if it has low osmotic pressure, it has low osmolarity. Okay, so those things are going to go together. Okay. All right, so this example here, classic example of a semi-permeable membrane inside of a beaker. Inside of this beaker, we have a solution, right? The solution, we have water, that's these little guys, and then we have a larger molecule like glucose, okay? The water can pass through that membrane, but those green molecules cannot, okay? So when you look at it, there's definitely more of the green molecules on the A side and less on the B side, okay? So again, so which side has more solute? The solute is the green molecule, so we'll say that's A, okay? Which side has higher osmotic pressure? So if it has more solute, then it's going to have higher osmolarity. It's also going to have higher osmotic pressure, okay? Now we'll look at these terms, hyperosmotic versus hypoosmotic, okay? The hyper means high, okay? So that's always going to go with the high osmotic pressure, okay? So hyperosmotic is going to be A, which automatically makes B hypoosmotic, okay? That just means lower osmotic pressure, okay? So which way is water going to go? Is it going to go from A to B or B to A? I guess left or right, okay? Yeah, go ahead and throw that up on your, sorry, go ahead and do that on the, there we go. Try it. You should be able to do it on your app there real quick. Just go A or B. Okay, give you about 5 more seconds. Just pick A or B. All right, anybody else? Gonna shut it off. And 3, 2, 1, shutting it off. Okay, so we got 64% of you saying A, 36% saying B. Okay, let's take a look. So again, hyperosmotic is going to go with high osmotic pressure. It's going to go with more solute, and high osmotic pressure has the ability to pull water towards it. Okay, so water is going to go this direction, right? It's going to go left. So A would be the correct answer there. Okay, any questions on that? Okay. Yeah, so obviously this is kind of what it's showing. The water actually travels that way, and we can get a situation like that where there's just way more water on the other side. So this is osmosis, right? Osmosis, we gave time for osmosis to happen, right? Okay. All right, so what I'll do, we're pretty much out of time here. So we've just got a couple slides left, and they're really all applications of this. So what I'll do is I'll start out next class with just reviewing these kind of applications of the osmosis principle. We'll take a couple minutes to do that, and we'll keep moving on, okay? So please reach out to me if you have questions. Again, if you haven't done that honor lock quiz yet, please do that. You're going to need to do that before the lab quiz on Thursday. Reach out to their tech support if it's not working for some reason, okay? That's your best bet, okay? And have a great weekend. Remember, you got to do that Master Name P by class time. And remember, you can start working on that chemistry lab as soon as 7 a.m. on Monday, okay? All right, guys, thanks a lot. Good job getting through your first week here, and we'll keep on moving on, okay? Have a great weekend. We'll see you guys soon.
Bye. Thank you.
Bye-bye.
Thank you.
Yeah, thank you. Bye-bye.
So I have a question.
Yeah.
Do you surf before every class on Thursday?
Say that one more time.
Do you surf before class on Thursday?
Oh, I'm hoping to get into that routine this semester, but we'll see. Yeah, it would be like an early morning, like 6 a.m. type surf. Yeah, you surf early morning sometimes?
Yeah, sometimes. Maybe I'll see you.
Okay, that'll be fun, man. Yeah.
Thank you.
Cool. All right, Cam. See you, man. Everybody else?
I had a quick question as well.
Yeah, go ahead.
So whenever we don't get to like finish the scheduled presentation or lecture, we should always go back